What is bandwidth? Bandwidth describes the maximum data transfer rate of a network or internet connection. It measures how much data can be sent over a specific connection in a given amount of time. For example, a gigabit Ethernet connection has a bandwidth of 1000 Mbps or 125 megabytes per second. An internet connection via cable modem may provide 25 Mbps of bandwidth. Bandwidth is used to describe network speeds. It does not measure how fast bits of data move from one location to another. Since data packets travel over electronic or fiber optic cables, the speed of each bit transferred is negligible. Instead, bandwidth measures how much data can flow through a specific connection at one time. When visualizing bandwidth, it may help to think of a network connection as a tube and each of the bit of the data as a grain of sand. If you pour a large amount of sand into a skinny tube, it will take a long time for the sand to flow through it. If you pour the same amount of sand through a wide tube, the sand will finish flowing through the tube much faster. Similarly, a download will finish much faster when you have a high bandwidth connection rather than a low bandwidth connection. Note: bandwidth also refers to a range of frequencies used to transmit a signal. This type of bandwidth is measured in hertz and is often referenced in signal processing applications. Bandwidth is the difference between the highest and lowest frequency in signal technology, which is possible in a certain transmission channel. Due to its physical properties, each transmission channel has a lower and upper limit frequency. The larger the bandwidth, the more information can be transmitted per unit of time. For analog signals, the bandwidth is in Hz or Hz, or in kilohertz, kHz, or megahertz, MHz measured. For example, an analog telephone knows a lower cutoff frequency of 300 Hz and an upper cutoff frequency of 3400 Hz. This results in a bandwidth of 3100 Hz, which is completely sufficient for a transmission of voice data. The term bandwidth is used, although not quite correctly, the transmission of digital signals, although this usually means the data rate or transmission rate. The data transfer rate is calculated by the number of data units per unit time. The smallest transmission rate is the bit, so the data transmission rate is often referred to as the bit rate or units of bits per second, or the BPS. The data transmission rate, which can be transmitted maximum error-free over one channel, becomes channel capacity called. In the transmission of digital data, the transmission speed depends on the bandwidth in the selected encoding. If one bit is selected as the code per hertz, the transmission rate measured in bits per second. Bit per second corresponds to the value of the broadband at 200 MHz, that is equivalent to 200 Mbps. If you encode 2 bits per hertz, you get a bandwidth of 400 Mbit per second. What is data transmission, or the transmission mode? Transmission mode means transferring of data between two devices. It is also known as communication mode. Buses and networks are designed to allow communication to occur between individual devices that are interconnected. There are 3 types of transmission mode. These are the simplex mode, half duplex mode, and full duplex mode. Simplex mode. In simplex mode, the communication is unidirectional, as on a one-way street, only one of the two devices on the link can transmit, the other one can only receive. The simplex mode can use the entire capacity of the channel to send data in one direction. Example, keyboard and traditional monitors. The keyboard can only introduce input, the monitor can only give the output. Half-duplex mode. In half-duplex mode, each station can both transmit and receive but not at the same time. When one device is sending, the other can only receive and vice versa. The half-duplex mode is used in cases where there is no need for communication in both directions at the same time. The entire capacity of the channel can be utilized for each direction. Example, walkie-talkie in which message is sent one at a time and messages are sent in both the directions. Full duplex mode. In full duplex mode, both stations can transmit and receive simultaneously. In full duplex mode, signals going in one direction share the capacity of the link with signals going in other direction. The sharing can occur in two ways. Either the link must contain two physically separate transmission paths, one for sending and the other for receiving, or the capacity is divided between signals traveling in both directions. Full duplex mode is used when communication in both directions is required all the time. The capacity of the channel, however, must be divided between two directions. Example, telephone network in which there is communication between two persons by a telephone line, though which both can talk and listen at the same time.